a to the power of m times a to the power of n. According to index laws, this can be simplified to a to the power of m plus n because it has something to do with these two bases being the same. Today on MathBase, we'll look at some examples to understand how this index law works, and then learn about a few other index laws similar to this one. So apparently when a to the power of m multiplies a to the power of n, it simplifies into a format where m and n will add each other. In other words, the powers will add each other because the bases are the same. This will make more sense using an example. So if you had 8 to the power of 3 times 8 to the power of 1, using our definition from the previous video, we would say that 1 is multiplying 8 3 times and then multiplying it one more time. So there'll be 3 8s happening here, followed by one more 8. And because they are all the same numbers, there's basically 4 in total, or 3 plus 1, meaning this can be simplified as 8 to the power of 3 plus 1, or simply 8 to the power of 4. So all this index law is doing is grouping the same bases all together based on the quantity or the powers. Now, a very important thing to keep in mind is that this index law is not simply written or read this way. It can be read the other way as well. That means a to the power of m plus n can be separated into a to the power of m times a to the power of n. So for example, if you had 7 to the power of 5, this can be written as 1 times 7 5 times. And if you want to split this into two separate multiplications, it's completely up to you which way you want to do it. You can group these two 7s together with these 3, or you can do the first one on its own with these 4, something like that. So you can say 1 7 with 4 7s, so that's 1 times 7 to the power of 1 times 7 to the power of 4. And we can just ignore the 1, it's not really necessary to show that. Or you can group it as the first two 7s with the next 3 7s, which would be 7 to the power of 2 times 7 to the power of 3. The main point to keep in mind is that this index law can be read and used both ways. Here's an index law that is very similar to that. A to the power of m divided by a to the power of n. They say that when this divides and has the same base, it will equal to a to the power of m minus n. In other words, a division version can be rewritten in terms of subtraction. And the easiest way to understand this is to use a fraction form. So for example, if you had 8 to the power of 5 divided by 8 to the power of 3, you can rewrite it as 8 to the power of 5 over 8 to the power of 3. And this expands into 1 times 8 5 times on top, and 1 times 8 3 times on the bottom. When they divide, 3 of them will cancel from each side, leaving you only with these two 8s. And so we could say that this is 8 to the power of 2, which was obtained because 8 was to the power of 5 minus 3. And you can also go backwards with this. So if you had 8 to the power of 7, you can rewrite it as 8 to the power of 10 minus 3, for example, which is 8 to the power of 10 divided by 8 to the power of 3, or 8 to the power of 10 over 8 to the power of 3, because the law can be read backwards. Things get a little more confusing from this point on. A to the power of m times b to the power of m looks very similar to the first index law we looked at, but the bases are different while the powers are the same now. And this can be simplified as a times b, all in brackets, to the power of m. As usual, let's use an example to understand this. A to the power of 3 times 2 to the power of 3 have different bases but the same power. It's all to do with grouping things together. So we first have 3 8s followed by 3 2s. And with multiplication, you can always rearrange them and write them in any order you want. So you can say 8 times 2, 8 times 2, 8 times 2. And you can basically just group it 3 times this way. And that simplifies to 8 times 2, 3 times. It's a little less intuitive than the previous laws, but just remember that because the powers are the same, you can actually group them or factorize the power out from that multiplication. And you can also read it backwards. So 5y to the power of 3 can be split into 5 to the power of 3 times y to the power of 3. And on this point, I just want to caution you guys that these two expressions have very different approaches. A times b to the power of 2 uses this index law, which means it can be split into a squared times b squared. But if you try to do this for the first expression where they're adding each other, so a squared plus b squared, this is actually wrong. You can't do that. What you're supposed to do is write it as a plus b times a plus b, and then expand from there to get 4 terms. I've seen many students make this mistake with square roots as well, like square root 16 plus 9, which is supposed to be added together first to give you 25, which then becomes square root of that is 5. Many students will simplify it to 4 plus 3 and then add it together, which is obviously wrong. So just bear this in mind. Additions do not change into anything, only multiplications do, which is pretty much the entire point of this topic. Indices are all about powers and multiplication, not addition. So here's the division version of the previous index law. A to the power of m divided by b to the power of m can be put together or grouped together as a fraction a over b to the power of m. The alternative version is a to the power of m divided by b to the power of m, which is grouped as a divided b to the power of m. It's up to you how you want to write it to remember it. This is probably easier to remember if you group it with the previous law of a to the power of m times b to the power of m equals a times b to the power of m. But just remember, different bases with the same power can be grouped such that the power comes out. An example of this would be 5 squared over 6 squared. You can group it as 5 over 6 all to the power of 2. This technique is particularly useful when you want to simplify things in a very quick fashion. For example, 10 squared over 2 squared. While you could work this out by taking 100 and dividing by 4, it's probably easier for most of you to just take 10 over 2, group that into the power of 2, which becomes 5 squared, and that gives you your 25. So these all mean the same thing, but this is more preferred compared to this other version. Index laws are usually there to provide shortcuts, not to make things longer. And as before, remember the opposite is true. 7 over 3 to the power of 2 can be split up into 7 squared over 3 squared. Just like any other law, this can also be read backwards. Now here's the final index law, similar to the others. A to the power of m all to the power of n. Because the powers are factors of each other, one could actually rewrite this as a to the power of m times n. An example of this is 7 squared all to the power of 3. So there are 2 7s happening inside the bracket, but this is happening 3 times, and so it would be 7 times 7, 3 times. In total, we can see that there are 6 7s, or in other words, it's 2 times 3, and so that's why it's just 7 to the power of 2 times 3, or 7 to the power of 6. It's all about how it groups, so if you had 8 to the power of 3 to the power of 2 outside, that means you have 2 groups of 3 8s. So there's 3 8s happening inside the bracket, but this is going to happen twice, which means in total there are still 6 8s, because 3 times 2. Another thing to keep in mind for this law is that you can write the powers whichever way you want. So if you had 2 to the power of 3 all to the power of 4, it can be rewritten as 2 to the power of 4 to the power of 3, because the powers are multiplying each other anyway, so it doesn't matter which way you write them. This trick will be very useful to know when we start dealing with fractional powers, like 4 to the power of 3 all to the power of half, because you can then rewrite it as 4 to the power of half all to the power of 3, and that's much easier to work out. And I'll discuss this in a future video to do with surds and square roots and all that stuff. So just to summarize, even though I've taught you 5 different index laws, you only need to remember these 3, because the division versions are simply the opposite of these 2 index laws. So when you times, you add, but if you divide, then you minus. And in this case, if you times, you will still times, and so when you divide, you still divide. It's more helpful to remember how they are defined or how they work, rather than remembering word for word how everything is written. And if I were you, I'd try to remember them going backwards rather than forwards, because students don't really make mistakes going forwards in these formulas. They tend to make them when they're going backwards. So writing them backwards tends to help prevent those mistakes. So I hope you guys found this helpful. If you did, then please like the video so that YouTube can recommend this to other viewers as well. Let me know what you think down in the comments below. Which areas do you struggle with the most when it comes to index laws? If you haven't joined the channel yet, then please click the subscribe button and ring the bell to get notified about the next video. Thanks so much for watching, guys. Have a good one, and I'll see you next time.